Hi everyone, it's Miss Sweeney. I just wanted to do a little review today of quadratics in vertex form and how they translate and transform. So the vertex form we have looks like this. Okay, what does the A value do to change this? And this isn't notes, this is just a quick review. Okay, what does changing the A variable do? It can make it wider. You can make it skinnier. You can also determine whether it goes up or down. I'm going to skip down here to what does changing the H variable do to the graph? The H variable moves it left or right. If it's a positive H, it goes left. If it's a negative H, it goes right. So the opposite of what you would think. What does the K variable do? It makes it go up or down. Positive K goes up. Negative K goes down. Okay, so that's just a quick review of a few things there. Now I want to go over a few situations where I have a graph and I want to know how is it different than the parent function. The parent function looks like this. Okay, not completely drawn to scale, but it does look like that. So how is this vertex, how did it move away from that vertex 0, 0? So if I write it out in words, I'm going to zoom in here to this picture. If I write this out in words, this vertex goes down 2, and then it goes left 1, 2, 3, 4. Okay. This goes down 2, left 4. It also looks like it got a little bit skinnier. Okay. What this is telling me about the basic equation that looks like this, this is our parent function. What this info is telling me is that if I look at that parent function, it means the A value, if it got skinnier, it's got to be bigger than 1. So I would be taking a guess here because I don't know exactly what the A value is. I know it has to be greater than 1. Let's just, for an example, it could be something like 2. Okay. Then I have my X. I know it went left 4, so that means I need a positive 4 here. And it went down 2, so I put my negative 2 here. That's an example of what an equation could look like. Okay. Moving on to this one. The parent function is this. It kind of looks like it's about the same width. So I don't think the A value is any different here. So the A value is no change in my opinion here, other than the A should be negative. The reason that the A value should be negative is because it flipped. It was facing up. Now it's facing down. Okay, so you definitely need a negative A value here. Okay, if from the parent function y equals x squared, we know we need a negative here. We have our x. Did it go left or right? That's what would be put it here for the h value. So remember, from this basic form, next comes the negative h. So how did it move left or right? So from here, it went right 2. Okay, so going right 2, all right, that means I would be putting negative 2. And then my k would be, does it go up or down? It does not. It stays on that x-axis, so I would not put anything here. Okay. Let me do one more example because this one doesn't go left or right. Okay. It does, however, though, seem like it gets, that wasn't my greatest sketch, sorry. Ignore that. Ignore this line. It does seem like it gets fat, it gets skinnier. So I think the A value should be larger than 1. It should get skinnier. Okay. I do notice that it moves downward. So the K value, it goes down from 0, it goes down to negative 6, so down 6. So my parent function looks like that. My new function, I need a value that would make it skinnier. So like once again, I'm just going to approximate 2. I have my x squared. the reason I don't need the parentheses is because in that normal function, a times x minus h squared plus k, in here, the h, all that's in those parentheses is adding that h in. That h makes it go left or right. This vertex doesn't move left or right. It stays here, okay? It just goes down. So all I'm going to need to do is add that -6 for the down part. Okay, so these are just a few quick examples that I wanted you to pay attention to help you with the quizzes today. All right. If you have any questions, please join my video call today. It will be posted on Classroom. Okay, have a great day.